This is the Nomad module from Radiomaster. It is a transmitter module designed for ExpressLRS, and it supports the new Gemini X functionality. Now, if you don't know what Gemini X is, it literally is you having your cake and eat it. And what I'm going to do today is walk you through what this module is. I'm going to talk about the new Gemini X capable receivers as well from Radiomaster, but I'm also going to spend a bit of time explaining exactly what Gemini and Gemini X is and how it differs compared to normal ExpressLRS. Now, at the start of the video, we will talk about the module first, and the parts about Gemini and Gemini X will be about halfway through. There will be timestamps down below as well if you're interested in seeing that part. Now, before we get into it, I just need to be clear in saying that I did not pay for this module. Radiomaster sent this over to me to review. However, they have not paid me to make this video. They have not seen this video before it's been published, and as always, my thoughts are entirely my own. Okay, so we have the new Nomad transmitter module and their new DBR4 receivers specifically designed to be used with it. Now, we're going to start with the transmitter module first, and then we'll move over to the receiver later on. Okay, so the new Nomad module from Radiomaster is specifically designed to be used with ExpressLRS, and it supports the new Gemini crossband or Gemini X feature. Now, if you don't know what that is, it is dual band transmission at the same time, sub-gigahertz and 2.4 gigahertz at the same time, giving you the best possible link redundancy. Now, if we take a close look at the module itself, the first thing that you'll notice is that there are two antenna outputs, one for one band, one for the other. But what is really interesting about this module is that it isn't restricted to one particular band on one output. It is based on the new Semtech LR1121 chipset. In fact, there are two of them in this module, and that chipset is dual band capable in itself. So either of these outputs can be 868-900, or either of them can be 2.4 gigs. What you can't do is have one output doing 868-900 and 2.4 gigs at the same time. But what it does mean is this module can actually be dual 2.4 gigs, dual 868 or 900, or one 868-900 and one 2.4. Now, getting the module out of the box, the first thing you will see is that it does look like a nano module, and the front half of it is. And that is because this module, when it ships, is going to ship, I believe, with two back halves. You can see here, if I flip it around, this currently has the JR Bay back half. However, Radiomaster will also be including a nano fitment back half with the final production as well. Unfortunately, I only have the JR Bay fitment here to be able to show you today. Now, looking around the rest of the module, on top, you'll find the two antenna ports. These are RP SMAs. On the front, you will find two push button switches. It's a rocker on either side. Flipping it back underneath, you'll find an XT30 for DC input. That is 6 to 16.8 volt, a USB-C port for updating the firmware. And then if I flip it around on the side here, you'll see this little window. There's no display on this module or anything like that, but this little window is to allow the signals to come out for the backpack and the Wi-Fi functionality. The external housing on this module is machined aluminium, and as a result of that, the internal Wi-Fi wouldn't be able to get out of the casing, so they've put this little window on the side to allow that to happen. Looking around the rest of it, on that side there, you can see we have a Gemini crossband logo, and then really on the back you have a standard JR Bay fitment on the plastic back half. Now, swapping this over will be really straightforward. There's a screw up there and a screw down there. You will simply undo them, and that will allow you to convert it into a Nano Bay module if you want to. Looking around the rest of it, there isn't really a great deal to show you other than that. If we just go back to the box a moment, included with the module also should be some antennas. I haven't actually opened these yet myself. Nope, there we go. So if I just get into the bag, you can see here that we've got these new antennas from Radiomaster designed to be used with this. These are dual band antennas. You can see that written across them there. So these both support 868-900 and 2.4 gigs, allowing you to get the full functionality from the module. Now, there is an articulating base on these antennas, so you can mount them horizontally or vertically if you want to as well. And really, from the module perspective, that's all there is to show you. Next, hopping over to the receiver. Now again, this is dual band. This is called the DBR4. This is their dual capable receiver. Exactly the same setup as we see on the transmitter. So the receiver is capable of transmitting on either 868 or 2.4 gigs, 868-900 I should say, or 2.4 gigs. If we just look at what we get in the packet, you get some wiring harness, which is always good for an ExpressLRS receiver. There are some gummies for mounting, and we'll talk about why you might need these in a minute. And then we've got the receiver itself in a nice anti-static bag. Looking closer at the DBR4 receiver, the first thing that you'll notice is it is a bit bigger than a traditional ExpressLRS receiver, and that is because it is that full dual band capable. Now, the receiver size is 27 by 27, and it has a 20 by 20 mounting pattern. You can see on this side here, we've got the dual RF chipsets. There are 4 antennas on this. That is because it is that dual band capable, but rather than it using dual band antennas, you can see that there are 2 antennas for 2.4 gigs. So that's the first 2.4 gigs antenna, and that's the second 2.4 gigs antenna up there. And then you've got dual antennas for 868-900 as well. Unlike the transmitter that uses a dual band antenna for each output, this is using 4 antennas, all with their own individual UFLs. Looking closer at the layout on the receiver, you can see we've got our dual RF chipsets. That is the LR1121s. You can see that one heads out to a power amplifier to our antennas, and that one does the same up there. This does have a full 100 milliwatt telemetry power capability. So you've got 1 watt of RF power on the transmitter and 100 milliwatts of RF power on the telemetry return. If we flip it over to the other side, you can see our ESP32 there. We've got a button which will be used for various functionality, including binding with ExpressLRS now as well. And then we've got our pads down here for soldering our wires for our typical CRFS connection. Now, looking around the rest of the receiver, you will see there are some additional pads broken out as well for other functionality. We'll take a closer look at that under the microscope in a minute. Now, at this point, I want to take a bit of time to explain exactly what the differences and the benefits are of Gemini and Gemini X compared to the standard ExpressLRS modules and systems. Now, the first thing to understand from a hardware perspective is that the standard ExpressLRS module or radio has a single transmitter in it, whereas a Gemini and a Gemini X module has 2 transmitters. A Gemini module will have 2 transmitters on the same band, i.e., both transmitters on 2.4 gigs or both on 868-900, whereas a Gemini X module is capable of having 2 transmitters on independent bands. These Gemini X modules can have 2 on 2.4 gigs, 2 on 868-900, or 1 on 868-900 and 1 on 2.4 gigs. So this allows you to have the most options. On top of those hardware changes, the software is then able to take advantage of that and introduce some new benefits. For instance, the standard ExpressLRS system is a single transmitter, as I've said, and it sends that data out in a serial manner. So you have each packet of data being sent one at a time at a rate that you have chosen in the system. If you want a longer range link, you can slow the data rate down and increase the packet size. But if you want a really low latency link, you can speed the data up and then have smaller packets, allowing for really low latency. The great thing with ExpressLRS is it has all of these modes available, but they all share one slight downside in that there is only so much redundancy that you can build into a single packet of data. And if that whole packet is missed by your receiver, your drone will not update and you will get a choppy control link. As a result of that, and to try and improve redundancy, the ExpressLRS dev teams introduced the D modes or the Deja Vu modes. These, for instance, in D500 send the same packet twice. So for instance, normal ExpressLRS would send your first packet, jump frequency, send your second packet, jump frequency. The D mode sends the same packet twice, but still on 2 separate frequencies. So for instance, packet 1 is sent, jump frequency, packet 1 is sent again, jump frequency. As a result of that, you're sending the same packet twice, increasing the opportunity for your receiver to be able to pick up that packet. But the downside is you're increasing latency because you're having to send every packet twice within the system. D250 works exactly the same, but instead of sending every packet twice, it actually sends every packet 4 times across 3 separate frequencies. This then does massively improve redundancy, but that then does come at the penalty of a little bit of latency. The real benefit of the D modes over the standard operating modes is that if you're operating in a high RF noise environment, you're giving your receiver multiple opportunities to pick up that packet of data. Now, whilst this all works really well, as I've said already, the downside to the D modes is latency, because you are only able to send the packets in a serial manner because these modules only have one transmitter. This is where Gemini comes in, because rather than only having one transmitter, you now have two. And as a result of that, instead of sending each packet one behind the other, you can now still send two packets, but you can do them in parallel. So instead of sending packet 1 jump frequency, send packet 1 jump frequency, you can now send packet 1 twice at the same time on two separate frequencies across the two modules. Furthermore to that, you can even take things to the next level, because you can still have your D modes, but then do that twice. So for instance, whereas I said the D mode on standard ExpressLRS sends two packets on two separate frequencies, with a Gemini module, you can send two packets on each module on two separate frequencies, or what is 4 packets across 4 frequencies, again increasing the redundancy. Or on D250 mode, you can go as far as sending 8 packets on 6 different frequencies, again massively increasing the redundancy. Where Gemini X comes into this is that you're then splitting that functionality across the two bands. Standard Gemini is the double transmitter on the same band. Gemini X is the two transmitters, one on 868-900, one on 2.4. This means not only are you having that increased redundancy, but you're then splitting it not across just different frequencies, but across completely different RF bands. Now, as a result of the move to this new LR1121 chipset in these modules, there are some changes to the modes that are available within the ExpressLRS system. Now, this chart from the ExpressLRS dev team nicely shows what these modules can do. You can see we have 2 antennas, 2.4 gigs dual frequencies, 2 antennas, sub-gigahertz dual frequencies, i.e. 868-900, 2 antennas, sub-gigahertz and 2.4, so 1 on each. Double the packets, 2.4 gig on double the frequencies, double the packets sub-gigahertz, and then double the packets, 1 on sub-gigahertz and 1 on 2.4. This chart shows the difference in modes that are available. For instance, on our old 2.4 gigs SX128 times chipsets, we had our FLRC modes, which was 1000, 500, D500 and D250, and then we had our LoRa modes in 500 Hz down to 50 Hz. On our old 868 and 900 modules, on our low band over here on the right, we had our maximum rate of 200 Hz on LoRa and our low rate of 25 Hz. On these new modules based on the LR1121 chipsets, you can see there is some crossover. So you can see we still have our low rate LoRa modes up here. We still have some of our LoRa modes in the middle here on 2.4 gigs, but there are changes to the modes that are available as well. So for instance, down here, we now have a LoRa 150 Hz and a LoRa 100 Hz, which is our Gemini X mode, our dual transmission on different bands. In our low band, we now have a 250 Hz mode, 50 Hz faster than what we had before on our old modules. We have a full 200 Hz mode now, and if you look at the bottom, there is now a massively fast full 1000 Hz mode coming on the new module on the low band. Alongside this, there is also a D500 mode at 500 Hz available on the 2.4 gigs band on these new modules as well. But what you will notice is right now we don't have the ultra fast modes on these modules on the 2.4 gigs band like we had on the old SX modules. The fastest mode on these modules in 2.4 gigs is our 500 Hz. You no longer have those FLRC 500 Hz as well as 1000 Hz modes that you had before. Now, the next thing I'm going to do is walk you through the modes that are available on this module as it comes from the factory. Between me actually recording parts of this video and it going live, there has now been a release candidate version of ExpressLRS 3.5 that actually adds more modes than I'm going to be showing you next. We'll look at that when we have a look at the spectrum analysis testing later on, but what I'm going to show you now is the official firmware support modes that you get with this module from the factory. But as always with ExpressLRS, that is always developing, that is always changing, and there will be continued development, especially around the fast modes on this as we move forward. Now, just walking you through the options and modes that is available. First of all, with regards to the antenna modes, we have the option of Gemini, which it's set to at the moment, which is dual transmission, whether that be dual transmission on the same band or separate bands. We then have antenna 1 only, antenna 2 only, or the switch option. Now we're going to leave it on Gemini a second. When we go up to the modes, we have the following available in 2.4 gigahertz. We have 50 hertz, 100 hertz full resolution, 150 hertz, 250 hertz, 333 full resolution, and 500 hertz. You no longer have the D modes and the F1000 modes like we saw in the previous system. They have changed in this and they are only available on that old SX chipset. You also don't have that fast F1000 mode on this chipset as well. If we though skip then forward one more, we then jump into the low band modes. 868-900, we have 50 hertz, 100 hertz, 100 hertz full resolution, 200 hertz, 200 hertz full resolution, 250 hertz. Now we do have this higher 250 hertz option available, unlike we had before in the SX chipset. The older chipset was limited to 200 hertz, so now you're losing the very fast 2.4 gigs modes, but you're gaining the X modes, which we'll look at in a minute, but also some extra speed in the low band. We then have the X modes. Now the X modes is dual band, 2.4 gigs, and the low band, either 868 or 900. We have X1000, X150, and that is the two X modes that are available. So again, the maximum that you can have in the dual transmission mode is 150 hertz. We now have one of the antennas transmitting on 2.4 gigs and one on 868-900. Right now, as you've seen, these modules have probably enough modes for 95% of users out there. The only ones that are missing is those really fast 1000 modes like you get on the original modules, but I do believe the dev team are working on it, and it is something that is going to come to these modules in the future. And when that happens, it's going to basically make these modules an all-in-one for every single use case, although there are going to be some differences depending on the chipset that your receiver uses, because remember, this isn't just about the chipset in the transmitter module. It is going to be dependent on the chipset on the receiver as well. But as we move forward, I suspect we will see most manufacturers just transition away from the SX chipsets in the original modules and over to the LR chipsets in the new modules. And then as soon as we see some of the additional features in ExpressLRS 4 and onwards, it's going to be a real one for everyone. Now, the next thing I want to do is just give you a bit of an overview of this functionality on my spectrum analyzer. Behind me, you can see we're spanning from about 600 megahertz down the bottom end up to 2.7 gigs at the top. So we're going to be able to see both high band and low band at the same time. In the middle, you can see the screen on my Boxer, and I've got the Radiomaster Gemini module installed on it here. Now, I'm currently running a dev build of the firmware, which gives me access to the new features that we've also seen released in the ExpressLRS version 3.5 RC1. This has the new modes that I'll show you in a second as well. And really, more than anything, I just want to give you a demo of how this looks on the band. Now, as you can see at the moment, we're in 200 hertz low band. That is this carrier that you're seeing here. You can see that there's a carrier here and a carrier here. Please just ignore these. That's a mobile phone carrier that I'm picking up, and this is my Wi-Fi in my house. You'll actually see it change quite dramatically when we move into the ExpressLRS up in the 2.4 gigs band. So, as you can see, we're on 868-900, and that's the carrier that we're seeing there. Now, the modes we currently have available are as follows, and these aren't actually in order, but what we have is 200 hertz in low band, we have 100 full in low band, we have 100 in low band, and then we have 50 hertz in low band. There are other low band options available as well, which I'll show you in a minute. They're just not in order on this dev build of the firmware. Next, we have the 2.4 gigs modes. Now, if I just save the 2.4 500, you can now see that that carrier has shifted from the bottom end down here, and it has moved up to here. So we're now transmitting on the 2.4 gigs band rather than the 900. We're still acting as a single module output at this moment in time. Within the 2.4, you've got your 500 hertz, you've got your 333 full, you've got your 250, you've got your 150, you've got your 100 full, you've got your 50. Again, that's the standard modes in 2.4 gigs. If I then scroll down, we've got our first Gemini X mode. Now this is X150 and it is available in X100 full as well. If I now select this, what you will see is the 900 megs carrier reappear, but we will retain the 2.4 gig carrier. So if I click OK, boom, you can now see that the 900 megs carrier is there, but we're still transmitting on 2.4 gigs. So right now we are in Gemini X mode. We're sending the packets across two separate bands, giving you the best possible option for reception. Now, with regards to the modes from here, we've got X150 and X100 full resolution. They're the two X modes that are available today. If I then continue to scroll down, we've then got some additional options for the low band. Whereas earlier I showed you the maximum rate in low band was 200 hertz. There is actually a 250 hertz available now. Again, you can see that 2.4 gigs carrier go off. There is also a 200s in low. And then we've got our DK modes, which is our Deja Vu modes that I mentioned earlier. We've got DK500, which is our first Deja Vu mode in the 2.4 gigs. And finally, we've got our new ultra fast low band mode, which is K1000. This is that all new very fast rate low band mode that offers the same rates that we used to have in 2.4 gigs, and you can now have that ultra low latency fast link mode but in the low band feature. Okay, now just to do a quick teardown and also show you how you would swap the back part, although I don't have the nano back for this at the moment. So you're just going to take an Allen key. There's only 2 screws on this, so we're going to undo this one up here. And then there's one down in there, which I'm trying to get the fitment onto. There we go. There we are. And then once they're out, you will then feel the back section release. You may need to press that button in there. If you do, just be careful. There is a wire that goes between the two sides. So what I'm going to do is carefully pop this off the back of the module. There we go. And there, that shows you the inside of the main module there. We have our RF shielding up here for our main RF side of the chipset. We've then got our ESP32 there. Let me just see if we pop this board out. Now, you wouldn't need to do this if you were just swapping the back part. If you were swapping the back, you would simply just go this far and then stop at that point there and simply swap over the back panel. However, as you all know, I don't tend to stop at places like that. So then if we just give this a gentle pull. Oh, I'm missing. There's another screw down there. Look at that. I actually missed that one. There's another Allen key there. That seems to be holding the board in. I'm assuming that goes to the button board on the front. Not exactly sure. There we go. That released it. Then if I flip it over, You can then see the back of the board. What we've got is a big thermal pad there. So let me just get that into the light. You've got a big thermal pad there that goes to the aluminium heatsink. That's going to offer some nice cooling, and you can see on the board that went to that large copper area there. We've then down the bottom here got our buttons located down here on the bottom of the PCB, and there's also some extra connectors on this side of the board. We've got some ground. I think what I'll do is I'll get it under the microscope so you can see what those connectors are. Now, just reassembling this for a second, just to show you the fan layout, because as I took it apart then, I didn't really show you how that was done. This fan was actually held in with those two screws that I removed. So those two didn't need to be removed. It was only this one in the bottom corner that actually held the module into the aluminium plate. The fan then screws to the board, and then it is a centrifugal fan that throws the air out of the top there. If you remember, this part here mounts onto this thermal pad. So what this fan actually does is drag air in the front, drive that air up there, which then drives it, let me just get the buttons out of the way, over this heatsink area, which is at the top here, which is then attached thermally to the PCB with the thermal pad, and that then is what helps keep it cool. That's directly on the back side of the main RF chipset, so there's a really nice cooling setup on this. Should have no problems keeping this under control whatsoever. Okay, so looking at this board under the microscope, we'll start on this side here. So we have our ESP32 there. This is most likely our main ESP32 chipset for the ExpressLRS function. There is another ESP32 down here. This is the C3. That is going to be most likely for our backpack. We've got a Syllabs chipset there, which will be our USB connectivity. And then we've got some voltage regulation there, and then we've got our connector that goes out to our back port, whether that be Nano, whether that be JR Bay. Now, on this side of the board over here, we do have a UART, so we've got a TX, an RX, a plus and a minus. Then on either side of that, you will see some small Wi-Fi antennas. So on this one here, we have a small chip antenna for the Wi-Fi for the main chipset, and then there's another chip antenna down here, which will be for the backpack functionality. Now, if we just flip the module over to the other side, you can now start to see some of these other pads. So at the top here, you can see the fan connector. You've got the big area there for the cooling that goes onto the heatsink. And then if we work our way down from the top, we've got what looks to be a C3 enable pad. On the side, there's D4RX, D4TX. We've got a ground, a VCC, a 3.3 volt, a C3RX and a C3TX. And if we keep going down, let me just turn it side on. D4 enable, another ground, D4 boot, C3 boot. So there are some additional pads on the back of the board here if you needed them. And then obviously there we can see our buttons. Now, as I've said already, the RF chipset is shielded. I'm not going to unsolder that on this video today, but you can see our RPSMAs there going into that shielding. It doesn't pop off. It is soldered. And perhaps I'll take a look at one in the future, but here and now, we're just going to go to there. Now, whilst we can't see the new chipsets on the transmitter, we certainly can on the receiver. So, starting in the top corner, what you can see is we've got our antenna port on the first chipset, which is the 900 megs and 2.4 gigs, and then on the side, 900, 2.4. Now, there you can see the first LR1121 chipset, and then there's another one down there. The layout of this is, here you've got your main chipset, you've got a crystal there. If you follow the RF tracked up, so on this RF output, goes up into this little transistor here, which looks like a amplifier, and that goes up to our 900 meg side. And then there's a separate line that comes out again into a filter, into an amplifier, and out to the 2.4 gigs. So they're two completely independent RF paths on the same chipset. And then that is mirrored over here on the second chipset. So the second one is located down the bottom. And again, you can see those RF lines going out into there, into that chipset there. That looks a bit more than just a filter with all of the lines that are going out onto that. That then goes into there, then out into our 900 megs, and then out of in the 2.4 gig side over there. It is a mirrored setup, so basically the two chipsets have the same circuit, just in different places on the board. If we then flip it over to the other side, things will be fairly more straightforward on this side. So you've got your ESP32. We've then got our Wi-Fi chip antenna located there in blue. You can see that just there. If we look around, we've got some voltage regulation, a protection diode, our bind button, and then you can see there's various pads all over the boards on this. So you've got a UART over here with power. You've then got your resets, ground, digital D1 IO 2, perhaps, SCK, boot, all of these other pads here as well, enable, which will be able to be used for other functionality in the future. Now, before I share with you some thoughts on where we are today with ExpressLRS and these modules, I just want to say if you're interested in getting one of these, there will be a link to it in the description, not only the Nomad module, but the new receivers as well. Those links will be affiliate links. Radiomaster are one of the only brands that I do use affiliate links with on this channel. However, that is because they are a fantastic brand that make great hardware. And if you're interested in getting one and supporting the channel, there will be a link down below. But if you want to go to Radiomaster's website, you can directly. You can just navigate to it and order them up if you need to. Now, as for sharing my thoughts on Nomad and where we're at today with ExpressLRS with Gemini X. Now, obviously, I haven't flown this today. This video isn't about flying this. We know how ExpressLRS works in 868-900 and we know how it works in 2.4 gigs. What this is, though, is a amalgamation of everything in the past. It is literally, you can have it all if you like, because this is all in one more than we have ever seen before. The reality now is, with Gemini X, you have a system that allows you the choice via software. You no longer now have to worry about hardware, because whereas in the past, you'd have to choose your module type. If your radio had ExpressLRS built in, most of them had 2.4 gigs. And whilst you could just put a 900 module in the back if you wanted it, we're now in a position with these modules, not only will do each band, but you have the Gemini functionality as well, allowing you the redundancy. And literally, you can choose what you want for your specific need on the day, and this module will do it all. With regards to the quality of this module, it is top notch. I got no complaints about. The only thing I can't comment on is the nano connection, because I wasn't sent it. Moving on to the receiver, I think it's really great to see. Again, has that dual RF chipset. Obviously, size-wise, it's not as small as the likes of the EP series or the RPs from Radiomaster, but it is a receiver that gives you all of the options under the sun. But I'm sure we're going to see more smaller receivers come with the new LR chipset in the future as well. You're going to see receivers that allow you to do the dual band, but just with the single transmission rather than the dual band on the dual transmission. Really, more than anything, we are now hitting the pinnacle of RC control links, because in the past we have seen lots of development on new systems. ExpressLRS came, we had the 2.4 gigs, 868-900, and you had the new modulation modes. Now it's getting to the stage of RC control links are done. There's no real major development that you're going to see in the future other than modes that are going to be able to be added via software. When it comes to hardware, this really is the future. Does it mean there won't be even more options? Maybe lower band options, 400 megahertz, lower maybe, higher options as time goes on as well if bands become available. We're obviously going to see frequency allocation move around, but what we have here today from a general user standpoint is a one-size-fits-all. This is one module that I can put in my radio and cover every use case that I have for at least the next 5 to 10 years. Now, as I've said, if you're interested in getting one, there will be a link to it in the description. I also want to say, please do check out the link in the description to the ExpressLRS Open Collective page, where you can donate to the ExpressLRS project. Whilst this hardware is developed by Radiomaster, we would not have all of this amazing functionality without the amazing work that the devs at ExpressLRS do. So not only do you want to consider buying the module, make sure you are supporting the project as well. There will be a link to their Open Collective page below. Now, that's it from me on this one. Please do let me know what you think in the comment section. If you have any questions, let me know down below as well. And finally, I just want to say, if you'd like to support the channel, please do consider checking out links to my Patreon, buy me a coffee, and there will also be links down below to my FPV wiki, as well as my Discord server as well, if you're interested in checking them out. Anyway, that's it from me on this one. Stay safe. I will speak to you soon.